live again. Yay! So, in the previous stream, I was looking at putting this stuff together, and I was grumbling a whole lot about funds and science and all of that. So, I didn't go do grabbing all the science, but I did make good progress on the persistent data, so I figured I would pop back in and talk about it. So, a couple things here. This is the first actual branch work I've been doing on this project. Haven't committed it yet. You see we're on a branch here called issue 4. And I created this persist module. And I started thinking about how to test it. I thought, well, let's make a vessel configuration called Farkos-T for test, and I'll put the issue after. So Farkos-T issue 4. The Farkos-T vessels are going to be real simple. You can see what it is here. It's just a command pod. In the future, I will have to arrange for our test vessel to use a command pod with unlimited storage, so we can test things without worrying. Maybe I'll just lock it down so that this particular Mark 1 command pod always has infinite storage rather than all command pods. We'll work that out. Or maybe I will edit one of the kOS modules. I don't know. Anyway, back to the code. So I set this up as a package, and I set up all the little thingies that I was working on. And I said, well, I need to test it. So I started writing test code. And I said, I have all this code that says do something and compare a result, do something else and compare a result over and over and over again. So instead, I wrote a built-in self-test, which could do things like I am going to have one method which always does the message logging, which is going to print to the console and log to a log file which is on the archive. So as we test, all of our output is going to get stored to the archive so I can look at it in an editor. And we have the normal things you would expect. Log result, log pass, log fail, expect true, expect false, expect equal, not equal to, a more generic expect that takes a test case string, a string describing what's expected, a string describing what's observed, and a function delegate to call. So actually expected and observed aren't actually strings. There's things that can be converted to strings. So for instance, equality, we use a delegate that compares them, and inequality we use compare it. This is a delegate that says not equal to, and so on. BIST, of course, has its own built-in self-test, so you can't ask BIST to test itself. And its output is going to have a whole bunch of pass and fail stuff. So this test is something where the human being needs to look over it. For other tests, it will say pass for everything, or it will say fail for a failed case. So when we actually get into testing persist, we'll be able to see what that is. So here's our test cases. Let's go ahead and run those tests real quick. I'm going to deploy my Farkos-T/issue 4 tester. And there we go. Oh, and I have upgraded the VAB once. So now we can go over 30 parts. Yay! We can use action groups. We can't use custom actions, so I can't yet automatically open the terminal. But if we open the terminal, we can see the test results that just ran. Well, we can see them if I stop showing my stuff, or I can move them over here. There we go. Kind of small. So this is our test running on the initial boot. So we roll the thing out onto the launch pad and we start it up. It should have no persisted data. Indeed, it does that. So let's walk down through our test code. We say, if we give it a name that's never been set, it's going to say it's not set. And we say get it, it's going to give us a 0. And if we get it with a default of 37, so you can say get name default. So if it doesn't find the name, it'll give you back the default. It won't persist the default value, but it will get it for you. And we note that we see the 0, we see the 37, and we see that it is still not persisted. So just getting with the default doesn't persist it. Now we persist a value called magic 42. We assure that it's there, and we can see its value, which is 42. Now we have this thing called start count. So I am going to persist a start count, which is going to increase every time we run this go function. Now in a actual deployment, I probably would have this outside the function. So we might count our boots based on how many times we load the dependent module rather than how many times we execute the go function. We'll see. That may in fact be something that I put in the persist module itself. I don't know. Is it useful to have persist set? No, that's extra. Okay, so it'll be up to the mission to keep track of the number of times it is booted, alongside the flight phase and so on. Jebediah likes testing. See down here, he's happy. So if this is our first start, then get start count is going to return 0. We're going to increment it to 1, so we print start count as 1. And it's the first time through, so we're going to set phase to 1. If phase wasn't previously set, we're going to set it to 1. Completely arbitrary at this point. We have not formally started talking about flight phases and mission profiles. At this point it says cycle power to continue. So I am going to cycle power on this thing. Hold on. We've got our thing here. I can turn off the power. Now, if I did a revert to launch, it would reload local storage to what it was at launch. So that would wipe out our persist file. But if I just power it down and back up, that's kind of like you've lost power on orbit, or you switched away from the vehicle to go to somewhere else and you switched back. If you switch away and switch back, we restart the code. So now we start the code, and it's already run. So it goes and it picks up the data. The first part of it, we do the same thing again. Let me turn the VS Code back on. So this first chunk, I wanted to run that every time because if there was an error, if, for instance, persist was erroneously saying I have data, for instance, because it picked up a persisted file from the archive, then it would never run this. So I always run this. The important thing is it gets down here and says phase is present on start count 2. So we got start count 2, which means start count was 1, and we bumped it to 2. We got down here and we saw the phase number that we stored. So this is our first use case, is storing a phase number persistently, which stays across reboots. So no matter how many times we power cycle, it's going to come up with phase is present and correct. Let's do this again. Toggle power off and back on. See, phase is still correct. So phase is going to stay 1. Why is this saying expected 0, observed 1? I think I have a problem in my built-in self-test. Haha. So, phase is correct says not equal to 0. Okay, so that's not a good test. I want phase to be equal to 1. So for now, we're just setting flight phase 1, and we never advance from phase 1, so it should always be equal to 1. Now, if I power cycle, it will reload this. That's the interesting thing is, when we power cycle, it reloads all of our source code from the archive, but it keeps the same persist file. So we can get a new version of one of the flight phases, but retain all of the data that we stored previously. This is going to be important. So if we change code, we want to not change the semantics of any of the data we have persisted. change version of your utility, but you're not changing your data files. So let's go ahead and toggle the power again. So this is going to be start count 4, and it will say expected 1, actual 1. So we fix the test. There we are. So persistent data is working. At least we can persist a number. And I could test more explicitly. I could test a whole bunch of data types. But the fact is that in the code, let's look at the actual persist code. What I'm using is I'm using read JSON to read the object, and I'm using write JSON to write it out. So if I were to test this in more detail, what I would be testing is the JSON support in the C# programming language. And that's something that I think I can assume works. Because if it doesn't work, it's not something I can fix. I would have to write a completely different persistence mechanism, and at that point I would probably instead go see if there's anybody currently working on kOS and see if they can look at it. So our persist is working, and now we need to go to the next stage, which is to check it in and do a PR. I'm going to step through that. This is more of a software engineering stream right now than a Kerbal Space Program stream. So let's see, I go down, let's simplify our life a little bit. So here's our net change. I've got go.ks, I've got the persist, which is the thing I'm building, and I've got the built-in self-test package. So what I'm going to do is I'm going to first check in the built-in self-test package itself as a commit. So we can organize this as several commits along the branch. Second commit I'm going to make is to check in persist, and then the third commit is going to be to check in the test script. Now, if I were checking these in as commits along the line as I did the development, let's say this is going to be something that took me several days to do, I would have built the BIST as a separate issue, then would have gone in and started building at persist. I would have built the beginning of persist, and I would have built some tests for it. And then that would have gotten checked in. And I would have built in some of the capabilities of persist, and I would have tested that, and that would have got checked in, and so on. This would have iterated. So this is not exactly what I would do. Also, under T here is a test log for this guy. This actually ran several tests. I am not going to check this in. In fact, I'm thinking I can either explicitly delete it. No, I want to be able to, okay, I could delete it. I can set up a git ignore to ignore it. I can set up VS Code to ignore it, and I can set up just my head to ignore it. So we may want to check in log files, so I'm not going to hide it from Git. I'm not going to hide it from VS Code. I'm going to ignore it in my head, which means that it's up to me to look at these and decide whether it's passing or failing. And it's passing. I should have cleared this log before the last test set. In fact, I'll tell you what we're going to do here. Let's delete it. Let's get a clean test run. So if we do a revert, it's going to do the whole test from scratch. So we're going to revert to launch to run the whole test from scratch. Open terminal. So there's the first boot where there's no persistent data, and you notice it's got start count 1. Persistent phase set to 1, please power cycle. Toggle power off, toggle power on, and there it is again. It's all passes. Start count is 2, and we observe the correct phase. And this is as much of the log as we want to record. So now I can revert to vehicle assembly, go back, and this is actually, I want to log this. I want to actually check this in. So inside T, I'm going to have test logs verifying the results from each one of these. And that means that my full test that I do on the system, if I decide to start doing it automatically, will wipe these out and regenerate them, and then I will verify with Git that it's not changing the results here. We'll have better ways of doing this in the future if things get to be more insane software engineering. But for the moment, this means that gets checked in. So, not GitLens. GitLens is probably cool. It's been showing me things I don't think I really... Yeah, a lot of stuff that it shows that's really kind of cool. What I really want to do is do the commit. So the first thing I want to do is check in BIST. And so the stage changes just BIST, so we're going to commit that. Now it should have popped up something for me to put a commit message. Hold on, I will have to check my other tool here real quick. I don't think that created a commit. Push, compare with head. File added. So this is confused. I haven't been doing commits here. It's got a SHA, so why isn't it showing it here? Oh, I was looking at the wrong repository with the tool. Haha, that explains it. Okay, so that automatically created a commit whose title was persist data across reboot, fixes number 4. That's incorrect. So just because I'm working on an issue and I'm doing a commit doesn't mean I am resolving the issue. So we are going to undo the commit. So we now have this change staged. And you notice it put it up here. So I didn't look at the comment areas. This is add BIST package. Support construction of built-in self-tests, which, given our limited okay. There we go. Entry points. I like putting these in the commit log. That way, if somebody has access to just a Git repository, nothing else, they can still get some of this information. That's because I'm not writing the documentation in the source tree, and I should. I really should do that. But for now, my entry points are log line S logs text line to the test results. Result takes a CEO, logs test results for case C with expected. Actually, no. This will get very long. I'll just list the entry points. Logline, result, pass, fail, TF, eval, EQ, and ME. Okay, so the documentation has to live in the source. There's no way around it. I have to belly up to that responsibility. There's BIST. We're going to commit that. Next thing we're going to do is we're going to commit the persist package itself, which is entirely new. So we stage it, and we go up here, and we put a message in. Initial implement write gate ability to store name value pairs so that they are still after a reboot. But note, not a revert. Entry points. Sync, set, has, get, and reset. So sync will take whatever's in my set of persistent data and write it to disk locally. That just writes it to the disk on the vehicle. Set establishes a new pair and then pushes it out to storage. Has tells if you have one. Get gets the value or returns a default because exceptions are not a thing. And reset deletes the persist file from disk and clears the lexicon. So you can completely reset all of it. I thought I was going to use that during testing. I didn't test that. So given that I didn't test it and I don't need it, I'm going to get rid of it until I find out that I do need it. Because it presumes the person calling a reset absolutely knows that nobody else has to keep any persistent data across the next reboot. So any one module calling that would wipe out state for other modules. What I'm not doing is allowing you to say unset my value. I'm not sure how to remove a value from a lexicon. I would look it up and find it, but I don't think it's needed. It might save some memory. I don't know. You might store a big whopping chunk of data in the persist if you were changing orbits and then get rid of it later. But that's easy enough. If you're storing it as a lexicon, you just say store an empty lexicon under that name. So when you later get that name, you get back an empty lexicon. You say, oh, we're not in the middle of a orbit change. So I think we don't need a reset or an unset or anything like that. So we'll just do that. And I'm going to presume I didn't just break the code. I'm going to go ahead and check this in. There. Implement persist package. There we go. Well, I just checked in the version that has reset, so we're going to go one more. I'm going to say remove. This method is dangerous. Is not currently needed and likely to be dangerous. A module calling it would interfere with operations of other independent modules. Part of the idea of modularized software is to reduce the interactions between the internals. You want your systems to be cohesive, but you don't want extra coupling. So we want the modules to connect and work together and find ways without being coupled internally. We never want a change internally in one module to change how the internals work in another one. So commit. And now I'm going to add the test script. Exercises. The can optionally adjusted to test the BIST module. So we can uncomment a line that has, we're going to run issue 4 testing, run the BIS test too. Okay, and I'm going to commit that. And lastly, I'm going to commit the log. Confirmed, correct, operation of persist. And I think I can say fix number 4 like that. And that, I'm not sure whether that will close it or if that's a Jira thing. Let me do a quick check. GitHub. It shouldn't close the issue until I do a PR. So I can associate a commit. So let's see, they just say, let me say closes number 4. And as I typed it, notice it said 4 persist data across reboots. What if I could put that in the body, or if it has to be in the title? Now that's actually linking to someone else. Closing issues via commit messages on the GitHub blog. I'm going to make sure I get this right. I would just see if I could do this automatically. Okay, that worked. I've typed fix number 4 to hit return and automatically did that. So I could just say okay, that's good enough. So just test it, number 4, hit return, it puts it all in there. So as long as I keep my issues tight, it'll do that. So we now have this branch I've constructed. Bada boom. So what can I do here? Can I create a pull request? So merges changes from Farkos issue 4 to Farkos main title. Implement BIST, implement I think I need to publish the branch first. Okay, so I hit publish branch, and now I can compare the changes. So as a careful software engineer, I would go through and verify that I am adding these files. Interesting thing is I am making no changes anywhere else in the system. So anything that was working before will continue to work. So, yay. I didn't have to add my package to a list somewhere, or turn on a permission, or reconfigure XML. I just created it. So let's create the PR. So it says no tree view with GitHub compare changes. Oh, because I had one, and yeah. So pull request. I'm not sure why it says issue 4 pull request number 5. I may have done some PRs against this this project before. So here's my commits. Okay, now I personally prefer merge commits because you may be doing development on something other than the head, and merging it, if things work, is good. There are people that say you have to rebase and then test and then commit. But what happens if you have a dozen engineers and each one of them has a 10-minute cycle, and they all rebase onto master and they all run their 10-minute cycle, and then 10 minutes later I do my commit, and you come in and you try to do your commit, but you aren't on the tip, so you have to rebase and test again. Now on the one hand, that assures that everybody tests exactly what they are merging. Something to be said for that. On the other hand, if there are no merge errors, what you really want to do is have your continuous integration system taking care of doing the test. So I would merge it into main, and then it would go off to continuous integration, which would then say yes or no, and if it was a no, it wouldn't actually get turned into master. So merge commits have the benefit of showing you the actual history. They show you what I was doing against what was there, rather than pretending that I started off doing things that had a compile error because of something that occurred in master after I started. So it's a more honest history. So if I were to design the most robust thing, it would be keeping the merge, doing the merge, and then not committing that merge commit back to master until it had been tested. But once I do that, so it's only, you resolve all the merge conflicts and you have the merge system handle that. So you end up with, I don't know, you still have a problem of, if I've got a dozen people doing commits, we have to test each one in sequence. At some point you have to say, we're going to accept non-conflicting merges from several engineers and test the results. That's not going to be an issue with this repository, and fortunately I don't have to worry about large groups anymore, so yay! I believe I can merge this request. So I'm not going to say merge pull request. This is implement BIST. Actually, it's actually implement persist and BIST. See issue. So, issue 4, it's merged. Now take a look at my other tools. Actually, let's take a look at actually what's on GitHub. Sorry, just setting things up here. Apparently my main branch was unprotected, which is why I kept being able to force push to it. I'm going to stop doing that. I'm going to start using PRs to bring these things in. So, I think changes from here on aren't going to be just loosey-goosey. Okay, we're gonna. So that has set the protections. I'm requiring a PR. So default branch is main, branch protected is main. Let's go back to okay, so turn on yeah, so we can see that there is a PR which has been closed. We have 4 issues. Now, that didn't automatically close the issue. Let's take a look at what's happening over here. Issue 4. Successfully merged. Well, that's just the PR. Data across reboots. So how do I... Okay, so apparently from here, this isn't where I want to be to close an issue. Pull request successfully merged. So VS Code doesn't actually integrate the whole do everything. So let's go back to GitHub. And I should be able to close the issue. Signees, projects, milestone, development. Close issue. Okay. So our resolved, our closed is not planned, close is completed. Done. Yeah. Okay, so in theory, I can reopen this if there's a problem. It's a nice thing about issues. So we go back to issues, and we now have transfer science, ascent telemetry, and descent telemetry. We're also going to want to work on mission phasing. I'm going to have to think about it. It might be the next thing we should work on, but it's going to take some thought. Meanwhile, some of the other things we've got here aren't going to take quite so much thought. Transfer science is going to require custom actions. So I'm going to need to spend almost $1 million funds upgrading the VAB to phase 3, to stage 3, before I can transfer the science automatically. That's a do action. However, I can start working on the telemetry ascent and descent at some point. The question is that actually something I want to do close? Well, let's see what contracts we can get. If we can't really do much in the way of contracts but testing stuff, then that's the next thing up. Otherwise, our next thing may be to design appropriate vehicles for running tourists up to space and back, or into orbit and back. So what have we got? We got observational surveys all over the place. Now these are modest prices, which is why you want to do it with an airplane. We have 2 tourists. Orbit. He wants orbit. He wants orbit. This is good funding. And we've got 3 tourists. Orbit. Oh, so we've got 5 tourists that want orbits. Let's commit to that. Now, our next big thing is explore the Mun. It says it expires in 2 days, but we know this is going to come back. Simply head to the Mun and pass by it. Easy as pie. Yeah, right. We do not have the rocketry to do that yet. Let's see. Heat shield in flight. Heat shield in flight. Drogue shield in flight. So these are all in-flight things. These are required telemetry. Let's build a orbital rocket. Let's build a new orbital rocket. So, from memory, about 2,000 meters per second to get to orbit, another 1,000 to circularize, and some to deorbit. So, we want to do a new rocket. This is Farkos D/1. Let's see. Among other things, what do I have in the way of resources? Can I spend any money on science at this point? So I have 72 science, so I don't have the 90 science to get both of these. So I can do either advanced rocketry, which gets me the Terrier, which will make it easier to turn around on orbit. I don't know what these star shots do. Guaranteed. Now, I seem to remember at one point that when you did this, you had to spend additional funds to unlock individual parts, and I am hoping that's not the way things are working now. Now this guy says crew cabin. I might be able to send all 5 of them up in one shot. So this is under a ton. Capacity 2. So well, if nothing else, I can send up a crew cabin with a normal capsule with a pilot in the capsule. Now this gets us our launch stability enhancer. Decisions. I'm going to go for this one because it's got the bigger fuel tank that I can use. So, let's try this again. New. So we still have the problem that we're going to need a stay put neck if we put 2 tourists in this. pure tourist rocket, so there's going to be no science. None of this stuff. There's our return module. So below that, control, we've got our scriptable control system. I know that we need a inline reaction wheel. Okay, so we have radial and normal decouplers. Crossfeed. Just reviewing what parts I have available. Okay, so now all we just need to do is put engines on this sucker. Okay, so a Terrier with a 400, with just a 400, that already gets us some decent. Notice the thrust weight ratio is small, but you don't need it very much on orbit. That's enough to deorbit and come home, right there. Now, if we put a second one on, that's 741 meters a second, which can finish circularization and come home. Just for comparison, a swivel is much higher delta. Oh. Look at the difference in delta V. I had no idea. Okay, so this is so the Terriers stop if they're throttled under 10%. The ISP is 345 in the vacuum. We want to watch vacuum ISP on these guys. And this guy, the swivel, his vacuum ISP. So the vacuum ISP of the Terrier is much higher. Hey, Mike Jav, let me get your delta V stats here. So with the swivel, 2261. With the Terrier, that's 3000 3000 right there. This is more along the lines of what I remembered. Okay, so just the Terrier with this much fuel, it's 2000 meters per second. That's enough to circularize and get home. So that's what I was remembering, is that the Terrier doesn't require a lot of fuel. With the medium-sized tank, that's still over 1000. That's enough to circularize and deorbit. Okay. And the other potential thing is to do half the circularization with the next stage, and this stage just has this much. That still is 600 meters per second. But I think what I'm going to do is do that. So this is going to be circularization and coming home and doing any other tooling around I want to do. So I need to get this up. So we're talking a couple thousand delta V added to this. So let's see here. I need a coupler. So let's look at this for a potential stage. So this right here is a 1500 meter per second stage. So all it would require would be a little bit of help. See how much the Terrier helped us? This guy's steerable, so again, we're not adding fins yet. So what I'm going to do, what if I take this stack and I add 2 of them? So let's see, couplers. The simpler I can make this jobby, the better. Aerodynamics, put a cap on it. I don't think this changes any of the delta V's, but in reality it will change the aerodynamics. And that guy goes down there. So what if we put 2 of these up? Why can't I make this? What's going on? Let's try from scratch here. Coupling. I want 2 couplers about here. We're going to put on fuel tank. The coupler, another fuel tank, and an engine. I don't know whether I want to use a Reliant or the swivel on that one. That really needs to go lower, doesn't it? So pair of Reliance, well that's enough right there. And notice this is only 18 parts, so we got the fuel tank smaller, even just going without the SRBs. What happens if you used SRBs instead? Wait, there's got to be a reason for the SRBs to exist, right? So that's 10,000 funds. That's 13,000. Okay, I will go with the cheaper solution. So this has the 2,000 that we need to get into orbit. Well, to get up to there. There's our circular. He can even handle some of the getting the rest of the way up if we don't get there. That's looking pretty good. Okay, let's move these guys down a bit so that they so we're resting on the solid rocket boosters instead of on the got it. Yeah, that's got it. It's going to be much easier to do these when I have the launch stability. So, as we're going up through the atmosphere, it really does help if we have some kind of aerodynamic control. So I'm going to put these on, even though I think this guy has enough of the control authority. We had problems with that before, and actually this is split. If I moved him down, see, that lowers our total delta V from these guys down to less than 2,000. It's still doable. Yeah, it's a difference in 300 delta V. Also, that means that we're keeping our engine here in reserve for higher altitudes. So if we look at him, thrust at sea level is 167, but in vacuum is 215. So as we gain altitude, we get a lot more efficient with that engine. So we do want him to be at higher altitudes preferentially. This also means that it might be a good idea at some point to think about our launch profile and think about do we want to run our liquid engines at less than 100% throttle to spread out their thrust along the entire thing rather than running them at 100%. So yeah, maybe we throttle back the engine so that instead of running at 2.01 thrust weight ratio, we run at a lower thrust, giving our, so we control our force based on our mass, and try to figure out a way to have the engine empty the tanks much later in the process. I don't know how that would work. What if I just set this? I'm going to try an experiment. I'm going to try doing a thrust limit of 50% on this engine. Let's see what kind of a profile we get when we fly that. That's real simple. So we still need a probe core on here because we're going to have tourists. I didn't leave a way to get a probe core on there. This is my only probe core, literally my only probe core. Does this... Okay, if this has some attitude control on it, curved net access, data transmitter. So what do things say when they actually have the ability to do? Okay, so it would have some torque on it. So let's see if this guy has torque. See, yeah, our Mark 1 command pod notes that it has torque. So if this guy doesn't have torque, yeah, okay. So Mark 1 is the only one with torque. So either we use a Mark 1 or we have to have one of these. Let's see. We didn't pick up the passenger module, did we? That's right, that was in the other one. We've got to get our science up to 45 so we can get that. So our electricity will be regenerated when this engine thrusts. But otherwise, we're not there. Can I put a couple of these in? We only need 2. So now we'll be able to store some power. I suspect we will be coasting for a while, and I wouldn't want our attitude controls to drain our batteries to the point where we couldn't get turned around and fire our engines again. So now we still have the problem with the parachute. So we have these radial mount parachutes. That looks pretty good. Although I think I'm going to put it side and side. Hopefully the fact that they're clipped in won't keep them from functioning. The other thing I noted from previously was, let's set the bin pressure up nice and high, and I'm going to increase the altitude some, and I'm going to spread these out. I remember these side mount parachutes. I want them to spread some. Don't know what the rigid attachment means. If I went through and set rigid attachment on everything, maybe it wouldn't be a bendy boy. On the other hand, that wouldn't be very Kerbal of me, now would it? Okay, star shots. I don't know what these do. They have dry mass, they have a stacking capacity. Trail, burst, force, duration, star size, launch velocity. I think this is just purely fireworks. Well, it's cool anyway. I need to get used to the idea of keeping my vessels low in the VAB, because once we get the launch stabilizers, it will land on the floor, and however high you are is how high you're going to be out there. Besides, down here you can see all the Kerbals running around, building your stuff. Okay, so I got parachutes. Okay, we are not taking any science. I will build a separate ship for going up and getting science. This is my tourist ship. Got to keep reminding myself. Radio. Tourists may need radio contact. But I think I can not worry about radio contact after they separate. So when they separate, they're going to lose their flight control system and their radio, and at that point it'll just be coming down gracefully, hanging from the parachutes. We have batteries. We have our thermal built in. If I had a bunch of things hanging off the bottom, I would put on some struts. So for instance, when we build our science vessel, if there's a bunch of science hanging off the bottom of the capsule, I'll put struts on so that we don't bang our instruments on the ground. The neat thing is that these have some decent stress tolerances on them. They can land at 10 meters a second. I think this science stuff, this guy, yeah. So if you land faster than 6 meters a second, you will lose your science junior. And let's see here. What else? Got a payload bay, which we don't need. Couplings, we're using couplings. I am still using the add-ons that give me MechJeb everywhere and kOS everywhere. I apologize, I still haven't turned that off. I need to. But in the spirit of launches to come, I'm going to add a MechJeb. So we honestly have MechJeb on our vessel now. In fact, I'm going to add MechJeb on the front here. So we haven't used these yet. These are 275 to 305 ISP each. It's a decent ISP. It's not as good as the Terrier. 345, hold on. 305. Yeah, it's not as good as the Terrier in space. It's better than the Terrier lower down. So this would be like high atmosphere stuff. So for instance, if we had another stage in the middle, because we were carrying something big, say something to go to Mun, these could start to come in handy. Or you could use these on the Mun ascent. Basically anywhere that you can't have radial and you can't have a coaxial engine. We have never used the hammers. So let's see, ISP is 195 and it's 200-ish, 300-ish. Yeah. Now this guy is an adapter for larger fuel tanks. So there will be fuel tanks with larger radius. And indeed, there's one of them. We don't really need to use it yet. But for instance, the capacity on this is 99 liquid and 121 oxidizer. For these, the FLT 400 is 180. So it's the capacity of this is just a little over that. So it's 200 versus 220. Okay. So as you build bigger rockets, we're going to get engines that are wider. We'll get more of these fuel tanks. Not using it yet. Kind of silly to put the FLTX 220s out there and then try to put a small engine on the bottom. If we had a way of mounting engines, if we had a way of mounting two of these on here, that would be kind of cool. But with just one, it just looks kind of silly. Still, it's a lot of fuel in a short vertical space. Okay, so there's our problem if the bendy rocket gets too tall. We shorten it down by using those. But I think this package looks good. What are we at? We're at 26 parts. We're still under that 30 part limit that we were bumping up against so hard. Maybe I didn't need to upgrade my VAB quite so soon. Nah. Adding a lot of science to this would make a difference. And being able to go over that is good. Mass is 26 tons. We're still well under limit, so we have no problem at all launching this. So let's see, 1200, 1400, that's going to be 26. That's more than enough to get up to apoapsis. That right there is enough for circularization. We'll still have a bunch left there. So we're going to be up there with this top stage here, and quite a lot of Delta V available. So this is a kind of a base framework for what might be a nice utility tug. So we're gonna save this. Accidental over engineering pops. This is a $15,000 fund craft though. What can I do to bring that down? Okay. Step 1. BecJev is expensive. Radio is not needed. Only one radial is actually needed. That's too much fuel. That is 600 meters per second. That's enough to deorbit. This is... Oh, I need 2,000 and 1,000. Sorry. There's our 1148. That's enough to circularize and come down. And this is enough to get up and have some extra to get a starting circularization, so it's better. So we're down to 13,575. I think that's about it. Not a whole lot of extra stuff on there. How much are the batteries? These are only 80 each. I am not going to skimp on the batteries just to save a few funds. Okay, so now we need to write the code for this. Go back to here. So I think I am still on the development branch. Let's check the default branch back out. Okay, the default branch that I have is not yet updated, so let's go control. Refresh. So here's main. Current branch main is 6 commits behind origin main on GitHub, so we need to update. So now that we've integrated that feature, we need to bring it back into our local area. Pull. And I'm going to look at my other tool at what that looks like, and we now have main checked out. So apparently my real name is exposed in my GitHub repository. Okay, so if I ever decide I want to be anonymous, that's going to be a problem because my name is now in the logs. Oh well, I guess I don't need to be anonymous. Nobody out there is picking on small-time developers that are working on kOS code, right? Right, please. So we've done that, and now we have, here's persist. Persist now exists, and we can use persist if we want to. So I need to now build my code for Farsyte E1, and again, I am much more comfortable doing that elsewhere. I don't have to edit the whole thing there, but I like to at least creating directories and so on is something where it's best done outside of tools from Microsoft. Okay, so export. And yes, you can do this. It will do forward references for function delegates. Yay! Let's do split screen on this, and I'm going to model it after D2's code because D2 successfully did its stuff. and we're going to be doing things that are similar. And I'm thinking that just for funsies, I'm going to send these guys off and launch azimuth of 45, so it's going to do northeast. And I'm going to run them up to 80,000 feet because I think I have some extra delta V, and let's move them up a little higher. So let's see. Launching in 1 minute. What I really want to do is make a launch that launches at a designated launch time. So I should be able to say something like global T0 is time colon seconds plus 60. And then just have it launch at T0. In fact, what I want to do is global T0 is persist of T0. Oh, I could just use the persistence mechanism. Yeah. So we're going to grab T0 from the persistence mechanism, and then we're going to, well, what we want to do is if T0 isn't set, I want to set it, and this will just set the default. But if it's already there, I want to use it. I'm starting to think in terms of what happens when we restart. So this may be this is going to be my experimental test bed where I start thinking about missions. So we're going to have a global phase, actually local phase is persist get phase. So phase 0 is going to be we haven't launched yet. So the other thing I want to do is I don't need to persist a new value for phase until phase changes. Okay. Now T0, I'm going to persist a T0 like that. I'm going to say, well, it's going to be now plus 60 seconds. And that's not going to be official until I actually commit it. So can I do a switch on? Is there a switch statement in this language? Or am I going to have to write this as an array? Bada boom, bada bing, where is my document? So this language does not have a switch statement. So really what I want to do is I want to have an array of function delegates where each element of the array is a distinct phase. Evaluate. Let's see, at runtime, run the method for the current phase. So what do I want to do when it ends? I want to repeatedly do it run. Repeat until done. Phase code does something quick, and then when it may So each phase by default will just repeat over and over and over again until it's done. And when it's done, it explicitly sets to the next. So I want these delegates to run to completion quickly and return. So the idea is that if possible, we aren't going to reboot in the middle of it, but at any point during that, we could reboot, come back and start at the beginning of that function again and have it pick up just as if it's in the middle of its stuff. Which means that basically you're running a state machine one step at a time. And you update your final state and it gets pushed back out to persistent storage, and the next time you run, you're done. Delay between phases. So perhaps the delegate returns a number, which is how many seconds to wait for the next call. Okay, so phase delegate returns the delay until the next call to the So we now have an array which is the mission plan, a formal array called a mission plan, which is indexed by the phase number, and it says do something and then wait for a certain amount of time, and wait 0 is just going to be do it again. Okay, phase code does something quick and explicitly changes the phase number. Wait for the appropriate delay and do it again. Stores state in the persist system, updates phase when it is to step to the next, and returns the delay until the next mission phase call. So it's possible that as I refactor this, these POF calls won't be usable because the POF calls don't return until the phase is complete when we really want them just to do a step there. So I will have to refactor this so the ascend becomes an ascend step, and the existing ascend entry point will have to call ascend step. Which means that we may end up with more code than we want temporarily until we can retire this. We may need a different package for POF steps. Yeah, okay, different package. So, yeah, new package does things a new way. We'll keep the old package that does things the old way. You won't load them both. Okay. Which means that we are going to be spending a lot of time in code, and I haven't been showing my editor. So let's see, I think it might be a good idea to make the editor bigger on the screen because this is going to be all code now. I will be switching back to KSP for debugging and such. Let's see if I can expand this inside OBS. There we go. So let's see. Phase is going to start out at 0 no matter what we do. I don't need to know phase here. And all of this is, surely there is a key binding for commenting out. So VS Code keyboard shortcuts. Hey, there's a nice sheet. I found a quick sheet on the web which has all sorts of neat things. Control Shift A. Nope. Unconvinced. That should have toggled a block comment. It could very well be that block comments are not defined for this language. So phase 0 is we have not yet launched. So I am going to, instead of using POF, I'm going to use something called mission. Didn't think we were going to do missions today, did you? So new file. Bink, bink. So we are going to say export mission is the package. Plan is going to be a list of things. So how do we call a function with a variable number of parameters from the list? That's a good question. Let me take a look at the function call semantics here in kOS. I think your call site has to have the exact number of parameters as the callee is expecting. The callee can have optional parameters. You know, I think I'm just going to have to pass persistent. I'm going to have to use persistence for this. Okay, well, we'll use persistence for it then. Okay, and we are going to need local Farkos is import of Farkos. So we've got Farkos up so we can do events and store files. We've got persist up so we can track data. We have a Lex, Lex for the mission package itself. And now we've got a list called plan. And we're going to have go, so there's going to be mission go, which is what gets called to run the mission at the end. What I want this to do is I want to have basically a loop. It says until false, local phase is persist :get phase. That'll get a 0 if the phase isn't set. Local step is mission of phase. So if you ever set your phase number to an entry that doesn't exist in list, you're boned. Let me make sure that list 0 works. So many languages start list as 0, what they should, and then some say, oh, we don't like 0, we hate 0, we hate 0. All our math knowledge is from 1,000 years ago before they invented 0. Oh, we're nervous about 0, the first thing should be 1. Screw that. I believe it's a 0-based list. lists, other lists, list bodies. A list is a structure list. There we go. Yep, starting from 0. So what we're going to do there is we're going to say step. Local DT is step. So we're going to call the step, it's going to return a time, then we're going to say wait DT. So there is our mission executor. And that will continue working until the cows come home. There you go. So there's a mission executable. We need something to add a step. So function add. What we're going to do is we're going to say mission :add, but not mission plan. And what we'll do is when add returns, it will return the length of the plan when it's done. The other thing is this needs to be plan subphase. So rather than go to a T configuration, I'm going to use Farkos E1 to actually debug this sucker, or test it. And there. So we're going to say mission add phase 0. You know what? I do need some parameters on these guys. Because we may have functions. Oh. Okay, so how about this? Plan is a list. Each entry in it is a list whose first element is the delegate, and the remainder is the arguments. So inside the steps, you'll have arg sub 0 is yourself, and arg sub 1 is your first argument, arg sub 2, so on. That's not too bad. It's P, kOS, var args. Interesting. Apparently you can decide to Oh, I wonder. Let's see. Let's see if this works. Phase 0 has 0 arguments. Phase 1 has 1 argument. It's a 5. Phase 2 has 2 arguments, and they're a 5 and a Fred. Let's see if I can write add to do this. What we're going to do is I'm going to say parameter fn argc, and we're going to say local L is list of fn, and we're going to say until argc equals 0. And this becomes step. So a step is a list that has a function part and some parameters after it. I'm not even sure this works. This is based on some chatting between Dumbaratu and Cheers Kevin. Okay, the bug was the parameter check wasn't set up, so we can't do this. Oh, well. Okay. So we're going to stick with this. I will just have to have my parameter step functions expect a list of parameters rather than a okay, so there is really no var args. The other thing would be to use a lex. Yeah, that actually might be better. So basically the phase, and we give it a lex, which is the thing. So add, the parameters are the fn and the lex, and the step is list of fn and lex, which we can just do like that. So now we want to do a next. So inside my phases, I want to be able to say next. And next we'll say persist set phase to persist get of phase plus 1. So we're not going to count on if we stash persist get of phase in a local variable and use it, it means that we wouldn't honor any changes that anybody else makes. And somebody could change phase before calling next. And I'm going to do a back. And these are steps, so they are going to take a parameter args, which is the args list. So in theory, next and back could be used in a mission add. No, too complex. And do we want to be able to loop in these guys? When we do, I will set up a function to jump back. But next is a standard way of ending. You'd say return next or return mission next. So if we have phase 0 as our phase function, I can put in some lexes here, say alt 10, see what that does for us, and here we might have speed. Actually, this might have 10. Let's think in terms of an actual launch. So phase 0 would be launching to cut off, let's see, direction might be 45. Then we might have a phase 0, well, we'll use phase 0 in a different phase that might be direction 40. No. That would be something persistent. So we say persist, set, launch. So now any function can get a hold of launch azimuth and be stored in our persistent data. I'm wondering if we actually need arguments for our phases. I mean, some of them might, but this is potentially overkill. Let's just go with the list solution. So you do add, you're just going to pass a list to the phase. There. Make it real simple. So we'll do launch steps, we'll do ascend, set step. Coast up, circ, pause, decel, deorbit, decel, shoot. I think that maps roughly launch. At some point I want to add the auto stager in. Ascend, coast, circularize, pause, deorbit, decelerate, and shoot. And if all of these, well, so let's see here. Obviously there's some things about the mission that I want to store persistently. Others I want to have in the list. Launch azimuth has to be consistent, and as does target orbit, really. Oh my, I checked in a change to D2 that waits until max thrust is 0 before starting the stager. That's right, I was testing something. I hope my stager wasn't modified. Hey, I could have checked in modified code. Let's see here, stager says... Okay, that's the normal stager. Yeah. Cute is fine, readable is better. So for now, what I want to do is just set up some step functions here really quick. I could do those inside Emacs actually better than I could do it here. So what I'm going to do at each one of these is have it print something and then return it to lay of 1 after setting phase to next. Off screen briefly in Emacs so I can use editor macros. Sorry for the delay. Okay, so you probably saw it bopping things up as I did saves. So, for now we're ignoring our arguments. we'll have to figure that out as time goes by, what we want to put in there. If it turns out that there's nothing interesting for the arguments, then we won't put anything in. Otherwise, we might, when these become library things, we'll probably have this stuff. Oh, actually, that's a good idea. Let's go ahead and put that in. The question is, do I want all of the magic numbers that are here? Do any of these really need to be persisted? Well, I can either persist them, or I can store them into the mission plan. And I am thinking, what are the chances that I want to change the mission by updating the persist rather than have it locked into the mission plan? I probably don't want it locked into the mission plan, so yeah, I'm thinking that all of these steps are going to be taking their parameters from persist rather than from a bigger mechanism. So we don't need this whole list thing. So when we call step, it's just calling step. Boom. Yay, Emacs. So all of our library phase step functions are going to be controlled by values that are persistent. So it is possible for us at any time within our mission to reach into the persist file, or reach into the persist using persist set, and change parameters of subsequent steps. Let's test to make sure this is working, and if it is, I can start building up these phase steps in a new package that's parallel to but distinct from POF. So this is E1, so it should print all this stuff out. And next, and what we want to do is we want to have this say, well, if this is out of range, if phase is out of range. Okay, let's add a implicit end phase at the end of this function end, which is just going to be saying goodbye. So Varkos EV mission end called. It will never return. So unlike all of the other ones, it's just gonna, well, actually, let's just have it. What do I want to do when we get to end? I could have it just loop forever. Yeah. Text first time or every time. I have an idea. So we're going to implicitly drop down by an end. An end will just do that. So now when we get to go, I can say mission add by. There. Oh, that's the other thing. I need to turn these into hold on. There. I forgot that I was having to send delegates in there. So we're going to add a whole bunch of things together, and if we drop off the bottom, we will end up in by and end here. Mission signing off. End will just loop forever. Every second it will run end again. This also means that if we power down and power back up, we'll get back to end. How do we know? It'd be nice if we could detect that we had powered down and back up. I have to think about that. It'd be nice for a step to know it was resuming for a power up. I know what I can do. We can persist, set, mission. So we do mission first, true. Actually, let's do mission iteration. Yeah, I'm gonna keep several variables here. First of all, I'm going to say local mission iter is persist So we're going to keep a total count of mission iterations just for funsies, which will persist local mission iter total since cold, and enter and go as a warm start. So now what we're going to do is persist set iter since warm is 0. Do I want to do that? No, let's just do a mission iter. And we'll do mission iter at boot. So anybody in theory could pick up mission iter at boot, compare them, and notice that it's been recently since boot. So now what we're going to do here is going to say set mission iter to mission iter +1 and persist set Now that has a side effect that we're going to update mission iter each time we iterate. So the other thing is we need to update phase. We're updating phase in next. Good. Let's. There. Yeah, I know it's longer. A little more explicit about what it's doing. So this function owns mission iter and it is merely publishing it. Mission iter boot gets published at the beginning by an end. Blink, blink. Okay, we will update phase the next time it moves. Phase will be 0 when it's uninitialized. It will stay 0 until somebody bumps it, and that's okay. I'm ready to test Farkos E1. Let's make this smaller. So I'm going to do this initial test using the large size one. And this guy is going to be not booted. Okay, so that blat means somebody did something bad. Let's get rid of this stuff. Well, that's because that's a typo. The @ sign goes after the name. Okay, unexpected token P. Haha. Launch azimuth is, yeah, brain farts all over the place. So in theory, ascent step could change target orbit, and it would be in effect when we restart, wherever we restarted. And that means that I am confirming my decision to not put this 8,000 in the mission table itself. Keeping it separate allows me to adjust the parameter. So the only thing we'd want in the mission table were things that are specifically just can't change and it be the same mission. Okay, let's try it again. Undefined variable persist. So it's called go. Probably because I didn't import persist here. Now, because I'm using KSM files, I'm losing a lot of debuggability. So what I'm going to do is for this, I'm going to go into Farsyte.ks and turn off the compilation. Yeah, I think I'm just going to do it by commenting it out. No, I should really make it a conditional. Well, the only real way to shift is to also make sure I delete the KSM files. So, yeah, there is that. So we do that, and I'm going to need to revert to launch. I'm also going to need to go to the archive and make sure the KSM files have been deleted. Okay, so we still got a Farsyte.ksm in there. That's done in boot. To undo that, I would have to reload. I will not worry about Farkos. So this error is launch step amper incorrect number of parameters. Submission add launch step at. Expected 2 arguments to mission add. What did I do there? Mission add takes parameter step. Badly named. Add is a method on Alex. I will call this step. Yeah, step, go, and next should be all right. And yeah, not having easy access to the keyboard commands. Fortunately, I know if I hit Alt, I can do the right thing. Alt, edit, replace, find mission, add, and change it to mission, step. Replace all. Okay. Toggle power twice. Get suffix step not found in object list of 0 items. Plan : step. Mission.ks line 11. Okay. Okay, so plan as a list. So plan colon step should add plan colon add of step. Oh, the function, yeah. I really have to watch my name conflicts. Okay, so again, that's FN because there's something else called step. Actually, let's call it add phase, next phase. It's called by step. So this thing is a phase that I'm adding. Next phase, this is a phase number, this is a phase call. Which means calling that phase would be bad. So phase number, persisted as phase, distinct from phase function. So add phase and next phase. Go is still the mission go. Now we go back to here. And next becomes next phase. Got it. So this is a little more verbose, but that's all right. Okay, that looks good. So now I can refactor my steps into a new step file. So on the one panel, we're going to want POF because it has the stuff we're going to refactor from. And the other one, we are going to want a new file. I will call it steps of phases. Now, the refactor is going to take into account that the parameters are coming from the persistent data, and so we need to get the persistent data in, and we need to do one thing and return to get us to the next phase. This is going to be long and arduous, and I'm not going to record it. So I will turn recording back on when I've got that done. Bye.